Good evening, ladies and gentlemen. Thank you all for coming. My name is Travis Mabee. This is Bob Sabie. I'm a disaster reduction and emergency planning major here on campus. And we did a water assessment across campus. And this is down the toilet. All right, so our project goals and overview for this project. I guess our main view was to assess our water consumption habits across campus. And for the 2008 year, a total water charge of $672,860 was charged. And for the 2008, there was a total water use of about 88 million gallons of water. This doesn't, however, intake the irrigation system. All right, we wanted to audit two buildings. Two buildings being the Environmental Studies building and the Communications facility. We did this for two reasons. One being that they're each sub-metered, so we can look at the individual water intakes of both buildings. And we wanted to account for the age difference of the buildings. So this building, obviously, the fixtures are a lot newer, and in the Environmental Studies building, they're a lot older. So we wanted to focus on bathroom fixtures, and this was mainly toilets and urinals. And for old toilets, they run about 3.5 gallons per flush. And for new toilets, they run between 1.6 and a gallon per flush, depending if they have the dual flush handle. And urinals, they run about 2.5 gallons per flush and run anywhere from a gallon to a half gallon per flush for new urinals. So we also wanted to create a cost-benefit analysis from this, and that was another goal. All right, so significance to Western and Bellingham as a whole. So the students represent about a sixth of the total population of Bellingham. So any improvements we make here on campus will affect the community at large. Globally, there's a population increase, and it means we're going to be using more natural resources, more water. So we also want to look at the savings on this. So by using less water, we're going to be impacting the environment less, basically. And by using less water, we're going to decrease our water bill here on campus. All right, so we did a case study at Ferris State University, and this looked at a dorm building. They had 146 pre-1971 Sloan flushometers, and they used a minimum of 3.5 gallons per flush. They retrofitted all of these toilets and with two parts, Sloan A38 repair kits, which run about $12 a piece, and a pressure cap called a ConservaCap, which is a little diaphragm that goes inside the flushometer, and that runs about $13 a piece. These pieces basically shorten the flush rate of the toilet itself, so you save about a gallon per flush. And the results from this study was they saved on average about 38,000 gallons per month, which is about $305 a month, and you take that out to year, and that's $3,670. Now the cost to retrofit, to place all these individual parts in, was $3,650. And the return on their investment took about a year. However, this price right here doesn't take into account the man hours that it would take to put these pieces in. But we got an estimate from a maintenance mechanic, and he said that it would take anywhere from 15 minutes to a half an hour to replace these parts. So it wouldn't be that much work to replace most of the fixtures in the buildings. All right, so here's a picture of the ConservaCap. It's just the diaphragm that goes inside, and then this is the repair kit. And the cool thing about these is you don't have to buy a new flushometer and a new toilet, which if you're replacing that, it costs close to $500 to replace the whole thing. So this is kind of a short-term solution to filling save us money. So I'm going to hand it over to Bob here, and he's going to talk a little bit about our findings.
All right, thanks, Travis. I'm Bob Sabie. I'm an environmental policy major here at Western. I'd like to thank everyone for sticking around tonight and listening to us talk about toilets. And also like to thank Ron for all his help. He gave us loads of information in our assessment. Now, when we first started our study, we wanted to find a strong correlation between the number of students in a building and the water usage. We looked at the communications building and the environmental studies building. What we found was in the communications building, the ratio of students per water use was a little closer, and there is some variance in there. But when we look at the environmental studies building over here, we can see that the water use per student is a lot higher. Now, I have to admit my graph is a little off, and that just shows my competency at computers. Now, the communications building has about, on average, 3,200 students a day. We got this information from Troy Ragsdale, and he provided us with the enrollment for the number of students enrolled in each building per day. And yeah, like I said, that building, the students use about 2 gallons of water per day, and in the environmental studies building, they use about 3 gallons of water per day. So over the day, that's about 1,400 gallons of water more that the students in the environmental studies building are using. We also did a month-long analysis of both buildings. The average water usage in the communications building was about 34,000 gallons. The average water use in the environmental studies building was about 17,000 gallons of water. Now, this seems like square footage-wise, it seems like it should be about right, but the environmental studies building doesn't even have half the amount of students that the communications building has. There's some high variances in the weeks that we were looking at. For instance, one week we measured the water use on a Friday, and when we came back on Monday, the communications building used 21,000 gallons of water, which is more than it usually uses in a week. So that just shows that there's a need to keep a better track of monitoring the water usage. So we wanted to propose retrofitting the environmental studies building. There's 47 fixtures in the building, 30 toilets and 17 urinals, and replacing all of the fixtures with the porcelain and the flushometers would cost approximately $22,000. Now this is a best case scenario, which would give us the new toilets and urinals with a 1.6 gallon flush and the urinals with a 1 gallon flush. But obviously right now times are tough and money's short. So we found an alternative, which Travis had mentioned earlier, is the ConservaCap diaphragm and the Sloan retrofit kit. And we can retrofit all of those fixtures in the environmental studies building for $1,800. And that does include the cost of the man hours. If we did that, we would save about 3,000 gallons of water a week, and or 12,000 gallons of water a month, or 144,000 gallons of water a year. And if we expanded this to some of the other buildings on campus that have the older fixtures, we could potentially save anywhere from 500,000 to 1 million gallons of water on campus. Since it's so cheap and the payoff is so quick, we don't see why there's any reason that this shouldn't be implemented now. It doesn't take very long, and so we feel like this could be implemented over spring break, and we could begin saving water and money.
All right, thanks, Bob. Well, for our recommendations, we propose a trial run of the A38A repair kits and ConservaCap just to actually see if it's doing anything. We would monitor those buildings. And then we'd like to see more monitoring going on, be it the staff or students themselves with further studies. And then we'd also like to see sub-meters put in new renovations and new buildings, just so we can monitor and see where water is going. And then we'd like to further this study, we're actually going to take this class again. So we'd like to further this study and possibly look at dorms and look at more of the students' habits. And also, we'd like to get a removable meter that can be placed on older buildings. They're kind of expensive, but this would enable us to look at these older buildings in the dorms instead of putting a sub-meter in. But yeah, thank you guys for your time again. If you have any questions,